Hello students, this quick video will go over the 3 laws that helped lay the foundation for the experiments that led to the modern understanding of the structure of the atom. To begin with, there's the law of conservation of mass. This simply states, in a chemical reaction, matter is neither created nor destroyed. It's analogous to the first law of thermodynamics, which said the same thing about energy. In other words, the total mass of the starting materials, we call those reactants, must equal the total mass of the ending materials, we call those products. Let's take a look at an example. Table salt, sodium chloride. Pure sodium is this soft silvery metal that reacts violently with water. If you add that to chlorine, which is a very hazardous gas, you get table salt, which is one of our favorite things to add to food and happens to be crucial for our survival. If we add 7.7 grams of sodium to 11.9 grams of chlorine, we will get exactly 19.6 grams of sodium chloride. That's 7.7 plus 11.9. We will never get more or less than that because we're not creating or destroying any matter when we react these two compounds. To look at it from an atomistic perspective, here's sodium sitting in its solid metallic lattice. The gaseous chlorine is bouncing around. When we mix these two together and react them, they form a new solid lattice of alternating sodium and chloride ions, which is the compound in question. None of the atoms are, come out of nowhere. None of them disappear. So we have the conservation of mass. The next law is the law of definite proportions. This one states that all samples of a particular compound always have the same elements in the same proportions. This just codifies that a compound is defined in terms of what is in it and how much is in it. An example, sodium chloride, going back to the previous page. 100 grams of sodium chloride will contain 39.3 grams of sodium and 60.7 grams of chlorine. Similarly, 200 grams of sodium chloride will contain 78.6 grams of sodium and 121.4 grams of chlorine. We've got double the sodium chloride, so we've got double the amount of sodium and double the amount of chlorine. Similarly, 58.4 grams of sodium chloride will contain 22.99 grams of sodium and 35.44 grams of chlorine. And you can crunch the numbers on your own to verify that for yourself. Another example is glucose. Glucose has a molecular formula of C6H12O6. That means that every molecule of glucose, the compound, will contain 6 carbon atoms, 12 hydrogen atoms, and 6 oxygen atoms. So, 100 grams of glucose will contain 40 grams of carbon, 6.7 grams of hydrogen, and 53.3 grams of oxygen. If we double the amount of glucose to 200 grams, we similarly double the amount of carbon, 80 grams, the amount of hydrogen, 13.4 grams, and the amount of oxygen, 106.6 grams. You can also crunch the numbers on the 180.16 grams of glucose to verify that, indeed, there is the same proportion of carbon, hydrogen, and oxygen in this amount of glucose. So the law of definite proportions just means that compounds are always the exact same thing and made from the exact same things. The last law is the law of multiple proportions. This one states that when 2 elements can form 2 different compounds, the ratio of these elements to each other is always a small whole number. And the first example we'll look at is carbon monoxide, CO, versus carbon dioxide, CO2. If we hold carbon constant, there should be twice as much oxygen in carbon dioxide as in carbon monoxide. And that indeed holds true. If we assume that we've got 1 gram of carbon, then to make carbon dioxide, we'll need 2.67 grams of oxygen, whereas to make carbon monoxide, we'll only need 1.33. With that ratio, 2.67 to 1.33, is 2, as we predicted. Let's look at another example. Cuprous chloride, CuCl, versus cupric chloride, CuCl2. Hold copper constant and compare how much chlorine is in each compound. For 1 gram of copper in CuCl2, we'll need 1.12 grams of chlorine. However, in CuCl, we'll only need 0.56 grams of chlorine. 1.12 divided by 0.56 is 2 once more. So the law of multiple proportions tells us that you will always see these small whole number ratios even when you're comparing different compounds, as long as they have the same elements. To recap, the law of conservation of mass, matter is neither created nor destroyed in a chemical reaction. The law of definite proportions, samples of a given compound always have the same elements in the same relative proportions. And the law of multiple proportions, when two different compounds can be made from the same elements, the ratios between those elements are always small whole numbers.